Good afternoon, students. Myself Pragnesh Polara from Home Engineering College, Junagadh. Today we are going to learn some topics about a limit and we will solve some examples using the special techniques of limits example. In last session we have already discussed the idea of function and the idea of limit. That what will we learn from the last session, that what is the idea of the limit. The idea of the limit is that if we want to define a function, for example the function is f of x is equal to x square minus 25 upon x minus 5 at x is equal to 5, then we know that this function is not defined at x is equal to 5, because if we put x is equal to 5 in this expression, then the denominator will becomes 0. So we cannot define the value of this function at x is equal to 5, but we can approach the value of the function as x approaches to 5. When that means when we take the value of x nearer to 5, not equal to 5, then we can say that then when x is not equal to 5 but x tends to 5, which is x is near to 5, then we can say that this is x minus 5, x plus 5 upon x minus 5. This is the value. X square minus 25 is equal to x minus 5 into x plus 5 upon x minus 5, and this will cancel. So if we put as x approaches to 5, then the value of the function, if we put here 5, then the value of the function approaches to 10. That is the idea of limit. When we can say that limit x tends to 5, x square minus 25 upon x minus 5 is equal to 10. That means as the value of x approaches to 5, then the value of this function approaches to 10, and we can say in the limit form that limit x tends to 5, x square upon 25 upon x minus 5 is equal to 10. So that is the idea of the limit, and that after that we have discussed some basic rules, fundamental rules of limit. We will quickly look at that rules, revise that rules, and then we will quickly move to solve some example using the fundamental rules, and then we will solve some example using the special techniques. Okay, so if we look at the PPT, then these are some fundamental rules of laws of limit for addition, subtraction, multiplication, division. Okay, limit x tends to a fx plus gx is equal to limit x tends to a fx plus limit x tends to a gx. In the same way for the subtraction, then for the multiplication, then for the division, the same formulas are in the PPTs. Okay, verbally we can say that the limit of a sum is the sum of limits. That means if we take the limit of the sum of two function fx and gx, that will equal to limit of function fx plus limit of function gx. And same way for the subtraction, the limit of a difference is the difference of the limit. This is for the subtraction. This is the multiplication of a function with constant, and then if we take the limit, it equal to the c times limit of function of fx. And then for the multiplication, limit x tends to a fx into gx is equal to limit x tends to a fx into limit x tends to a gx. એનો મતલબ કે કોઈ પણ બે ફંક્શનનો મલ્ટિપ્લિકેશન કરી અને પછી આપણે જો એની લિમિટ મેળવીએ, અથવા તો એની લિમિટ મેળવી અને પછી એનો મલ્ટિપ્લિકેશન કરીએ, બંનેનો આન્સર સેમ રેટે રહેશે. શું કામ? તો કે this is the rule of product, that limit x tends to a fx into gx is equal to limit x tends to a fx into limit x tends to a gx. And same way for the quotient, here limit x tends to a fx upon gx is equal to limit x tends to a fx upon limit x tends to a gx, given that if limit x tends to a g of x is not equal to 0, because if we take limit x tends to a gx is equal to 0, then the denominator becomes 0, so that limit will be not defined. So we cannot take limit x tends to a gx is equal to 0. So if limit x tends to a gx is not equal to 0, then we can say limit x tends to a fx upon gx is equal to limit x tends to a fx upon limit x tends to a gx. These all are basic laws of limit, and if we look at one or two small examples based on the properties of these limits or the fundamental rules of limits. So if we look at this example, limit x tends to c 5x raised to 4 minus 13x plus 2. If we look at the rule of sum and difference, then we can write like this. First the limit of 5x raised to 4 minus limit of 13x plus limit of 2, and then if we look at the product and multiple rules, then this will equal to phi is a constant and x tends to c, so phi c raised to 4 minus 13c plus 2. In the same way, if we look at the second one, then limit x tends to c x cube minus 4x upon x square plus h. Directly we will use the quotient rule, because fx, if we take fx is equal to x cube minus 4x and gx is equal to x square plus h, then we can write like this: limit x tends to c fx upon limit x tends to c gx. This is the quotient rule. Then we will use the sum and difference rule, so that will equal to for the numerator, and this one is for the denominator. So after all, we will get the answer c cube minus 4c upon c square plus 8. This is the answer of limit using the properties of limits. So these are the some simple examples of limit using the properties of limit. And now if we look further, some more examples which are frequently asked in the GTU exams. There are some special examples. Here if we look at this example, limit h tends to 0, 3 plus h whole square minus 9 upon h. If we define capital F of h is equal to 3 plus h whole square minus 9 upon h, and we know that we cannot define this function at h is equal to 0, because if we put h is equal to 0, then the denominator becomes 0. But if we simplify the numerator, then we get capital F of h is equal to 9 plus 6h plus h square minus 9. So plus 9 minus 9 will be cancel, and we will get 6h plus h square upon h, which will equal to 6 plus h. Okay, so if we take limit h tends to 0, that means h is not equal to 0, h approaches to 0. So then we can use this method, and if we take h is not equal to 0, then limit h tends to 0, 3 plus h whole square minus 9 upon h is equal to limit h tends to 0, 6 plus h, as we have discussed in the previous PPT. So then if we put the limit h tends to 0, then the answer will be 6. So we can say that the limit h tends to 0, 3 plus h whole square minus 9 upon h will be equal to 6. The limit of this function is equal to 6. Okay, so this one is the one more example for the limit. Now we will quickly move to the some special kind of example which are frequently asked in the GTU's exam. So there are so many examples. First method is the factoring method, then we will take the example when the limit x tends to infinite. Then we will take some special results of limit and the example using that special method. જે આ ફર્સ્ટ મેથડ છે એમાં આપણે ફેક્ટરાઇઝેશનનો યુઝ કરશું અને ફેક્ટરાઇઝેશનનો યુઝ કરી અને લિમિટ કઈ રીતના મેળવી એનો આપણે એમાં આઈડિયાનો ઉપયોગ કરશું. ફોર એક્ઝામ્પલ એક્ઝામ્પલ નંબર 4 આપણે જોશું પીપીટીની અંદર, તો આપણે આઈડિયા આવશે કે લિમિટ વી વોન્ટ ટુ ફાઇન્ડ ધ લિમિટ એક્સ ટેન્સ ટુ 1 x સ્ક્વેર -1 અપોન x -1. એ વસ્તુ ક્લિયર છે કે જો આપણે એક્સની જગ્યાએ 1 મૂકશું તો ફંક્શનનો જે ડિનોમિનેટર છે છેદ છે એ 0 થઈ જશે. તો આપણે ડાયરેક્ટલી x ઇઝ ઇક્વલ ટુ 1 મૂકી શકીએ નહીં, પણ અહીંયા લિમિટ x ટેન્સ ટુ 1 છે, દેટ મીન્સ x ઇઝ નોટ ઇક્વલ ટુ 1 but x is approaches to 1. So if we factorize x square minus 1, so we will get x square minus 1 is equal to x minus 1 into x plus 1. What I have discussed in the PPT, we can't apply the quotient law because the limit of the denominator is 0. Instead we will need to do some preliminary algebra. So we will factorize the numerator and we will get x square minus 1 is equal to x minus 1 into x plus 1 and denominator is equal to x minus 1. So x minus 1 will be cancelled because x minus 1 is not equal to 0 because x is not equal to 1. So we can cancel x minus 1 and so we will get x minus 1 into x plus 1 upon x minus 1. And the limit x tends to 1 remains x plus 1. So if we put x is equal to 1, then the answer will be 2. So limit x tends to 1, x square minus 1 upon x minus 1 is equal to 2. This example we have solved using the factorization, right? The factorization of x square minus 1 is equal to x minus 1 into x plus 1. In the same way, if we look at one more example, if we look at this example here, limit x tends to minus 1, x square minus 3x minus 4 upon x plus 1. If we try to put the direct limit x is equal to minus 1, then the format is 0 upon 0 format. So we cannot apply directly that rule which is indeterminate form, right? So simply we will do what the title of this slide says. We will factorize the numerator. Okay, so x square minus 3x minus 4 is equal to x minus 4 and x plus 1, and denominator is equal to x plus 1 already. So x plus 1 cancel out and the x minus 4 remains. Okay, so limit x tends to minus 1, x minus 4 is equal to minus 5. So answer of the limit is minus 5 as x tends to minus 1. So this is one more example of factorization. In the same way we can do this example as I have discussed before starting this session, that x plus 5 upon x square minus 25. So this is 0 upon 0 format. X square minus 25 is equal to 0 because if we put x is equal to minus 5, and also x plus 5 is also equal to 0. So by factorization this is equal to x plus 5 upon x minus 5 into x plus 5, limit x tends to minus 5. So factor and cancel the common factors. Common factors is equal to x plus 5. So cancel the common factor and the remains part is limit x tends to minus 5, 1 upon x minus 5, which is directly equals to 1 upon minus 10, which is the answer of our question. So these are some example of factorization. This is the one more example. Okay, 4 minus x square is equal to 2 minus x into 2 plus x, and if we take the common x square from the denominator, that will also equal to 2 plus x. Then if we cancel the 2 plus x which is the common factor, then limit x tends to minus 2, 2 minus x upon x square, and if we put the limit, then we will get 2 minus x tends to minus 2, so 2 minus minus 2 upon minus 2 whole square So that is 4 upon 4 is equal to 1. So that is the answer of the question. And the second type of example is how to solve example using conjugates. The last limit evaluation method attacks the radical expression in the limits. Here we need to use the conjugate to make the example easier, because here if we look at the example number 8, then limit x tends to 0 in root x minus 3 minus 2 upon x minus 7. Here it is clear that in root x minus 3 here in the numerator, so it is quite difficult to solve example without using conjugates. Here we will use conjugates. If you try to solution, it will result in the determinate form 0 upon 0, and the factor, if we factorization here, that is also not very useful for us. So we will use the conjugate here. Here limit x tends to here the print mistake, limit x tends to 7, not x tends to 0. The conjugate of root of x minus 3 minus 2 is root of x minus 3 plus 2. So we will multiply numerator as well as denominator by root of x minus 3 minus plus 2. So we will get root of x minus 3 minus 2 into root of x minus 3 plus 2. That is a minus b into a plus b format. So we will get a minus b into a plus b is equal to a square minus b square. So here we will get x minus 3 minus 4, because root of x minus 3 square is equal to x minus 3, and 2 square is equal to 4. So that is equal to x minus 3 minus 4. That is equal to x minus 7. Okay, and x minus 7. So by the computing this one, we will get quickly the answer 1 upon 4. This is the one example. Then the same kind of example is here. If we put the limit t tends to 0, then the denominator is 0. So that is 0 upon 0 format. So here if we